Dear student, in last video we learned definition for electric current and what are the charge carriers in case of conductor. You learn. Along with that, what are the charge carriers in a semiconductor also we learn, and along with that, what are the different kind of charge carriers in case of liquid and gases also we learn in a last video. And in today's class we'll do continuation of that. It is nothing but elementary description of current flowing through a conductor. Elementary description of current flowing through a conductor. Elementary description of current flowing through a conductor. Dear student, especially while think about a conductor, I consider a good conductor, we call it as metals. In case of metals, just imagine this one is a one metal. It contains huge number of atoms. All the atoms containing electrons in a different orbits. And again that atom contain a nucleus at the center part that I already explained in last video. Either nucleus sutta, there will be different orbit that you learn. And this one is a first orbit, this one is a second orbit, this one is a third orbit, like that. If I consider a single atom, again first orbital in electron occupy agide, these electrons are strongly bound to the nucleus compared to the second orbit and third orbit or outermost orbit. In outermost orbit, what are the electron present? These electrons are loosely bound to the nucleus. The electrostatic force of attraction, or we call it as Coulomb's force of attraction between positively charged nucleus and negatively charged electron in the outermost orbit is minimum because of distance. If distance increases, force decreases. That you learn according to Coulomb's law. Either naduve force of attraction kadme irutte. This force of attraction is less. Due to that reason, e electron easily we can take it out, or these electrons are easily available for conduction process. E electron anna we call it as valence electron, that I explained in last video. This valence electron is also called as free electron. This valence electron is also called as free electron. And again, these valence electrons or free electrons are the major charge carrier, in case of conductors to get the electric current or electricity. If I consider any conductor, imagine this one is a conductor. This conductor is not under the influence of electric field or electric potential. And whatever electrons, or we call it as valence electron or we call it as free electrons present in this conductor, all these valence electron or free electron moving randomly in a different direction or all possible direction, like this, moving randomly. Due to that randomness, these valence electrons, they collide with ions. When they collide with ions, no electron moving from one end of the conductor A to another end of the conductor B. If no electrons are moving from one end to another end, automatically net transfer of charge from end A to end B is equal to 0. If no transfer of charge takes place from one end to another end B, automatically we can say that electric current is equal to 0. Reason is electric current itself is called rate of flow of charge from one end of the conductor to another end of the conductor. But without external electric field, remember this, without electric field or potential between ends of a conductor, no electrons or charged particle moving from one end of the conductor to another end of the conductor, automatically net transfer of charge from A to B is equal to 0. Then we come to know that electric current in the system is equal to 0. There is no electric current. The reason is without applying the electric field or potential, all the electron present in the conductor are moving randomly in a different direction or all possible direction. If one electron moving in this direction, another electron is moving opposite to that. Automatically in this system they collide to the ion. Due to collision, after collision also they start moving at the same speed or same velocity, and again they collide with one more ion. Again its direction changes but velocity remains same. We call it as elastic type of collision. And due to that collision, no electrons are moving from end A to end B. If no electron moving from end A to end B, automatically net transfer of charge from end A to end B becomes zero. So electric current becomes zero. To get the electric current across the ends of a conductor, we have to connect the battery. By connecting the battery, we have to apply the suitable potential. By applying the potential, we have to create the suitable electric field in a conductor. Electric field in a conductor. Just imagine, consider a conductor like this. Consider a conductor, and one end of the conductor, I call it as A, is connected to positive terminal of a battery. Another end of the conductor B, it is connected to negative terminal of the battery. And again here this entire part is positive terminal or positive. This entire part is negative. Automatically by connecting or by applying potential difference or potential between ends of this conductor, automatically from A to B there will be an electric field. Electric field is acting from A to B. And under this condition, whatever electron present in the conductor, each and every electron will experience the electric field. Each and every electron will experience the electric field. And again, when you're going to see these two diagrams, in initial diagram, all the electron, they are free to move without electric field or without electric potential, and due to their randomness they collide with ion. In each collision their direction going to change. Automatical net transfer of the charge from one end to another end is zero. So electric current is zero. And without electric field, each and every charger particle if I take or electron if I take, its path moving from X, it is a path tracer like the zigzag path. Somewhere here it reached to a point, this particular point. Now again this one is a path for free electron without electric field, without electric potential. When I'm going to apply the potential difference between two ends of a conductor, and every electron present in the conductor will experience the electric field. Due to this electric field, automatically whatever electron present in a conductor will experience the force. That force we call it as electric force. That force we call it as electric force. That electric force acting opposite to the direction of electric field, because electrons are negatively charged, it is always moving opposite to the direction of electric field. Dear student, you already know the formula for electric field. Electric field is nothing but electric force per unit positive charge. Here charge is denoted by letter E. I consider electron charge. Automatically force experienced by each electron is equal to E into E. It is a force experienced by each electron by connecting the battery across the ends of a conductor or by applying the potential difference between ends of a conductor. Due to this potential, each and every electron present in a conductor will experience a force. That force we call it as electric force. That electric force acting opposite to the direction of electric field, because electrons are negatively charged particle. Negatively charged particle always moving opposite to the direction of electric field. Automatically, due to this electric field, each and every electron straightly get drifted. Slightly get drifted from its initial path. Initially I said without electric field or without electric potential, path traced by the each and every electron, if I consider single electron, or each and every electron is like a zigzag path like this. By the application of potential or electric field on a conductor, path traced by the charged particle gets shifted like this. It gets shifted like this, or we call it as get drifted like this. Get drifted like this. It reached to a point x dash. Here, this one, the change in path by the application of or drifting of electron path by the application of electric field or potential across the ends of a conductor, that we call it as drift. With a particular speed or velocity, that velocity we call it as drift velocity. Keep this point in your mind, that velocity we call it as drift velocity. And this is the initial concept related to how to get the current, and automatically by the application of electric field, each and every electron experience the electric force. Due to that electric force, that force will bring the electron from end B to end A. There will be a net transfer of charge. There will be a net transfer of charge from end B to end A. If there will be net transfer of charge from one end to another end, automatically there will be a flow of charge from one end to another end, it leading towards electric current. That electric current is nothing but rate of flow of charge. Rate of flow of charge under steady condition, we denote it as I is equal to Q divided by T. The flow of charge takes place in a conductor by the application of electric potential and electric field is mainly due to process called drift. Without electric field, all the electron they moving randomly and they collide with ions. Automatically in each and every collision its direction going to change. One is moving towards left and the one is moving towards right. They collide. Automatically net transfer of charge is zero, no current. To get the current, we connected battery across that. By connecting the battery, each and every electron experience the electric field is acting from A to B. Opposite to direction of electric field, electrons are moving or get drifted with a force called Coulomb's force, is also called electrostatic force. Each and every electron experience a force. From that force, electrons are get drifted from end B to end E. Automatically there will be a net transfer of charge from end B to A. It is moving opposite direction because nature of electron is negative, and we get the current is equal to Q divided by T, rate of flow of charge. Dear student, we already learned about drift velocity. I told under the influence of electric potential or electric field, electrons are get drifted in a conductor. That drifting of electron leading towards the concept called drift velocity. And again I said initially path traced by the electron like the zigzag path like this. It is moving from here to here. And again by the application of electric field, path of this electron is get drifted like this. Path of electron is get drifted like this. It reaches to a point x dash. This separation we call it as drift under the influence of electric field. Here drift velocity is nothing but average velocity of an electron with which electrons get drifted under the influence of electric field. Average velocity of an electron with which electrons get drifted under the influence of electric field is called drift velocity. And dear student, here without electric field, this bolded line represent the path traced by an electron in a conductor. Under the influence of electric field, dotted line represent the path traced by an electron. Here x to x dash is called a drift. By using this, we can think about drift velocity, average velocity of an electron with which electrons get drifted under the influence of electric field is called drift velocity. It is one of the important definition for drift velocity. By using this, we can think about expression for drift velocity. Expression for drift velocity. To get the expression for drift velocity, if I consider any one conductor, just imagine is a conductor. This conductor got n number of electron. Imagine this conductor got n number of electron. Each electron got a charge is E. Just imagine each electron got a charge is E. E is the charge of each and every electron, and the length of the conductor is equal to L. Length of the conductor is equal to L. Area of cross section of a conductor is equal to A. I repeat, consider a conductor of length L, area of cross section A, it containing n number of electron. Each electron got a charge is equal to E. E is the charge of each electron. By considering this conductor, I can say that volume of conductor is equal to area into length of the conductor, that you learn. Area of cross section of a conductor is equal to A, length of the conductor is equal to L, volume of a conductor is equal to area into length. Now in that volume it contains, I said, n number of electron. In that volume it containing n number of electron. Automatically total number of electrons in that volume is equal to n into A into L. Remember this, total number of electron in that volume is n into A into L. Each and every electron got a total charge is E. Therefore net charge present in a conductor, I call it as Q net, is equal to n into A into L into E. The reason I said total volume of a conductor is equal to A into L. In that volume it containing n number of electron. Total number of electron in that volume becomes n into A into L. So net charge present in a conductor is equal to NaL into E. We call it as Q net. Is equation number 1. Once I get the net charge present in a conductor, I want to find out the electric current. From definition of electric current, we have I is equal to Q, I call it as net charge divided by time T. Here T is the time required to take the electron from one end to another end by applying the electric field or electric potential. And this end is connected to positive end, this end is connected to negative end of the battery. Here net charge from equation 1 we got N A into L into E divided by T from equation 1. This equation we can write it like I is equal to N into A into E divided by, or N into A into E into L divided by, I will take together L divided by T. L divided by T. Dear student, electrons are moving from one end to another end. If electric field is acting in this direction, electron is moving opposite to that with the force called electric force. Under the influence of electric field, electrons are drifted from one end to another end. And again here, distance covered by electron is equal to L in an interval of time T. Automatical length divided by T is the velocity, where L divided by T itself is velocity, but that velocity is under the influence of electric field. Electrons are get drifted. That velocity we call it as drift velocity Vd. Therefore, we got the equation I is equal to N into E into A. In place of L divided by T, we call it as velocity. That velocity is called drift velocity. This one is the relationship connecting between electric current with the drift velocity. This clearly shows that electric current is directly proportional to drift velocity. In a conductor, if there is a drift velocity, there will be an electric current. This one is an equation connect the relationship between electric current and drift velocity. We got the equation I is equal to N into E into A into Vd. The remaining things we'll discuss in next video. Thank you.